Ladies and gentlemen, we're looking at our fifth installment in Chapter 2. It seems to be going so quickly. So we're going to take a look at our if-then statements and deductive reasoning. And so what that means, ladies and gentlemen, is we're going to be using if-then statements and then applying laws of logic. Woohoo! You may be thinking, oh, Mrs. Woodard, I'm a high schooler. I have no logic. Oh, I'll work with you. I will work with you. We will get through this. All right, let's take a look at what the vocabulary we need in order to work in this, because there's a lot of new things we're going to talk about. We've got these if-then statements. The cool thing about an if-then statement is you actually see the words if and then. So it's a statement with two parts. The if part, which we call the hypothesis. Okay? This is kind of the part where you assume something. And then, and the then part, that's your conclusion. This is going to be kind of what you, this is what you assume. Your conclusion is what you predict. So an example of an if-then statement, let's see how far down I can move this. An example of an if-then statement would be if you watch the video. Then you do not get kicked out of class. So notice my if you watch the movie. I'm making some sort of assumption. I'm assuming you're going to watch the video. I then make a prediction. Then I'm predicting you will or do not get kicked out of class. Now, some of you may do something that does still get you kicked out of class, but what I'm telling you is if you watch the movie, then you do not get kicked out of class. That's an if-then statement. The hypothesis is the if part of an if-then statement. That's the part that you're assuming. I'm going to assume this is happening, okay? If it is sunny, if Mrs. Woodard has a smile on her face, if I come to class on time, you're going to assume that you do something. We then have a prediction that goes with that. And that's our next vocab word. That's the conclusion. That's the predict part. That's the part you predict. So, if it is sunny, then I will get tan. I'm predicting I'll get tan. If Mrs. Woodard has a smile on her face, then it will be a good class period. I'm predicting to have a good class period. If you come to class on time, then you can get started on your warm-up. So I'm predicting you can get started. That's the conclusion. It's kind of like the effect of what happens in the first place. We then have what's called deductive reasoning. We're using facts, definitions, properties, and these laws of logic, which is our if-then statements, to make a logical argument. Now this is where I feel like some of you will go, oh, but, and that's where we say, we're not throwing buts in there, we're just using logic. So if I go back to the part, if it is sunny outside, then I can get a tan. That's how I get a tan, is with the sun outside. So we're using that logical reasoning. So we go, well, what if you don't wear swimsuit, or whatever, you only wear clothes, or long clothing, or always wear hats, or you stay inside. Yeah. There's all these buts that go with it, but when we talk about logic, we're following sane reasoning, normal reasoning that everyone else uses. All right, so let's take a look at using these. We have the laws of detachment. These are a little bit wordy in some of them, but we find that we naturally use this laws of attachment without even knowing that word. I've been using this law of attachment for quite a while in my life, ladies and gentlemen, and didn't know that's what it was called. But what I want you to remember here is what I have up here in green. If the hypothesis of a true if-then statement is true, then the conclusion is true. So, for example, what does that look like if we talk about if the hypothesis of a true if then statement is true, then the conclusion is true. So if I walk in the rain without an umbrella, then I get wet. And so what we're saying is this is logically true. If you walk in the rain without an umbrella, then you'll get wet. Logically, we know that happens. So I can predict for myself that if I decide to walk in the rain without an umbrella, if I do this, if I make this true, okay, so if I make it true, then I know that my conclusion will be true. I know I will get wet. So that's not what that law of attachment does. To me, it's just more of the laws of logic. All right? And now we have this law of syllogism, which looks really wordy. So it says, if two statements are true, then the third statement is also true. That's what you guys are putting in your fill in the blank there. I read a room at the end of my line. Is also true. So what that means, if statement P, then statement Q. If statement Q, then statement R. So statement P, then commits R. So let's look at it this way. If you are in math, then you smile. All right. So this is my P. If you're P, then here's my Q. So then I need an if statement with the Q. So if you smile, then you are happy. So here's my Q. I said, okay, if Q is happening, then R is going to happen. So then what I can do then is say, let's just cut out the middle part. Let's cut out that repeat of Q, and we simply say, if you are in math, I can jump right to R. Then you are happy. And we know, ladies and gentlemen, that that is always true. And so that's all that this laws of syllogism is saying, is basically we can skip out the Q and we can jump directly to just Q, and if Q, then R. All right? All right. We need to identify the hypothesis and conclusion. So if I pass the driving test, then I will get my driver's license. The hypothesis is what you assume. So you're assuming, I'm going to look at that you will pass your driving test. So you assume I pass the driving test. Now, ladies and gentlemen, you have to make sure when you're doing your assignments that you tell me this is a hypothesis. So I should see hypothesis written down, colon, and then the specifics for that statement. The conclusion is what is going to happen, what you're predicting. So your prediction is I will get my driver's license. And that's as simple as what you're going to do here. We're just making sure that you can pull off these ifs and thens. All right. Now what we want to be able to do, guys, is take something that's happening and turn it into an if-then statement. So every game on my computer is fun to play. So what would we do? So we're looking at this every game on my computer. So if a game is on my computer, and I'm running out of room to write here, guys. Hopefully you can fit it all on the line. So if the game is on my computer, what are we assuming about that? We're assuming then it is fun to play. So we're basically taking that sentence and separating it into the beginning and the end and looking at what we know. I'm going to assume I have a game on my computer. I'm predicting that it's fun to play. I will buy the CD if it costs less than $15. These are kind of my favorite ones, ladies and gentlemen, because they give you your if. If a CD costs less than $15. Notice, ladies and gentlemen, I can't use the word it. I have to say what it is. So you have to tell me here in this first part in your hypothesis what you're talking about. You can't say if it costs. I need to know what it is. If a CD costs less than $15, then what are we assuming? Well, then we go back to the front of the problem. Then I will buy it. All right. You're assuming what's gonna happen. Okay. What happens? This is kind of like an action or a description for it. What happens is you buy that. Okay. So your follow-up is this: in a sentence that contains a hypothesis and conclusion, is the conclusion always stated at the end of the sentence? You need to explain and give an example. We're going to call this a checking class problem. All right, you guys are going to group up and share those answers, probably for your warm-up. And there is an example in your notes that you're going to be able to use for that. All right? All right, so our checkpoints. So you guys should pause here. We want to rewrite it as an if-then statement and then identify hypothesis and conclusion. So there's three parts: the rewrite, there's the hypothesis, and then there's the conclusion. So an angle is obtuse if its measure is 170 degrees. We kind of see that if there. So we have if. I can't use it, so I have to say if an angle measures 170 degrees, what do we know about it? Then it is obtuse. Okay? So we got to make sure we're looking and reading. Sometimes that hypothesis does come at the end, and our conclusion comes at the front. So what you would tell me your hypothesis is an angle. That's what you're going to predict. An angle measures, or you're going to assume, an angle measures 170 degrees. Your conclusion is it is obtuse. All right, now we got the laws of detachment, which are really kind of what you're going to look at a situation, you're going to look at an if-then statement, and you're going to decide what's happening. So, what can we conclude from this problem? All right, so let's take a look at our laws of detachment. What can we conclude from the following true statement? So we need to know that we're assuming that this is true. So if you wash the cotton t-shirt in hot water, then it will shrink. You wash the cotton t-shirt in hot water. So basically what you're doing is you've actually now done what you're predicting. You have acted out your hypothesis. Now you need to go to that conclusion and take a look and say, okay, what's going to happen? So the hypothesis of a true if-then statement, that's our first statement in there, the hypothesis, is true because of the second statement. So by the law of detachment, the conclusion is also true. So what are we going to conclude? We are going to conclude that the t-shirt shrunk. Ladies and gentlemen, you must use logic. Believe it or not, you can do that in this class. So there it is. You knew it. That's all you have to do is keep using that logic, common sense. All right, so checkpoints. Pause. Try this out, and then jump back into the video. If x has a value of 7, then 2x minus 3 has a value of 11. The value of x is 7. So what can we conclude? Here's my hypothesis. We're going to conclude that 2x minus 3 has a value of 11. They give me my hypothesis. They've given me that. So what can I conclude? I can conclude my conclusion. 2x minus 3 will equal 11. That's all it is. If you study at least 2 hours for tests, then you will pass the test. So here's my hypothesis. Here is my conclusion. So you studied for 3 hours. I actually acted it out. I see my hypothesis. So what can I conclude? I conclude I will pass my test. All right, so let's take a look. Now what we need to do is we need to decide, is the argument correct? Which argument is correct? We have to remember, guys, that when we're using these laws of detachment, we need to assume our hypothesis, not our conclusion. So if we look at this, if 2 angles are vertical angles, then they are congruent. My statement is only correct if I'm assuming that they are vertical angles. So this is what we need to start with. So we look at argument 1. Angle 1 and angle 2 are congruent, so angle 1 and angle 2 are vertical. We start with our conclusion here. I don't know just because they're congruent means that they're vertical angles. We've seen a lot of congruent angles in our diagrams. Not everyone was vertical. But argument 2 says angle 1 and 2 are vertical angles, so angle 1 and 2 are congruent. I see my hypothesis, then my conclusion. So argument 2 is the one that's correct. So this is what we look, guys. You can only use the hypothesis to prove the conclusion, not the other way around. It's like a one-way street. The if leads to the then. Now we need to use this law of soliloquisms, which means we're taking from P to Q, Q to R, and then we're saying P to R. So we're basically repeating that middle part, that's conclusion, twice. So write the statement that follows from the true statement. If the daily high temperature is 32 degrees or less, so this is my P. This is my first hypothesis. Okay, this is our P, if we look back at the notes. Then the water in the pipes is frozen. Here's my conclusion. And so that's Q. If the water in the pipes is frozen, so now I see Q written as a hypothesis, then the pipes will break. I'm looking at a new conclusion, and this is what we would call R. So what we're doing is we're cutting right to the chase. You leave out that middle part. We leave out the repeats of the water in the pipes being frozen. So how do we write that using the laws of syllogism? Start with your first hypothesis. If the daily high temperature is 32 degrees, so you're going to see that first hypothesis. Then, what do we write? Then the pipe will break. And so what we're seeing here is our last conclusion. All right. You guys have one last checkpoint. You're going to follow the syllogisms there, and this is going to be our other check in class.